Hello, everybody. My name is Josh Clayton, and today I'm going to be talking to you about my term project, which is called the Identification of Electric Vehicle Charging Stations through Geospatial Analysis. Kind of before we begin, I'm going to kind of go into the outlining why I chose this project. For one, we live in a warming climate. As it currently stands, transportation accounts for 30% of greenhouse gas emissions, in an attempt to curb those emissions, both policy and industry are coming together to make that happen. I found this a very timely topic to do my analysis on. Back on November 15th, 2021, President Biden signed the Infrastructure Investment and Jobs Act, which allocated $7.5 billion for roughly 500,000 chargers to be deployed nationwide. Now, that doesn't do the American people very much good if the typical electric vehicle is over $40,000. In order to negate those high costs and make them more competitive with combustion engines, Congress is also seeking to pass the Build Back Better Act, which provides that support of $7,500 to $12,000 for most electric vehicles. So you'll be able to see a 15 to 20% reduction in the cost of most electric vehicles, either upfront or as a rebate or when filing your taxes. And kind of lastly, most automakers are shifting towards 100% electric vehicle production by about that 2030, 2035 timeframe. They're seeing the trends in the industry and policies being made to incentivize the reduction of emissions. But in order for that to actually happen in a realistic fashion, those charging stations need to be there prior to their shift. So while automakers have, a 9-year timeline, charging station deployment needs to come sooner than that. Now, otherwise, you're kind of leaving out a majority of the country who they're just not fortunate enough to have public charging stations nearby or within their homes. And it's just not feasible otherwise if you can't accommodate the population with this giant shift in industry. And at the end of the day, it is a different perspective and a different mindset than having a gas car. And I'm going to get into that in a little bit. So before we get further, I want to go over some common terminology I'm going to be using pretty frequently to differentiate between the level of chargers. Now, the only types I'm going to be talking about are your level 2 and level 3 chargers. I did not use level 1 chargers within my analysis, which are your standard 120 volts, because that would take multiple days to charge. And it's not a realistic thing to kind of base your analysis on. It's inconvenient, so why would anyone switch? So from a level 2 charging perspective, you're looking at about 35 mile per hour charging rate, which should take roughly 8 hours to fully charge your vehicle, and on a completely empty battery. Otherwise, if you have a level 3 charger, which charges around 900 miles per hour, that would take roughly about 35 minutes to completely recharge your vehicle. Again, on an empty battery. I don't think most people are driving 300 miles a day, but if you are, that's kind of what you'd be looking at. But if you are charging, to fill up your 100 miles that you drove today, that should only take, a couple hours at home, 2 to 3 hours at a level 2 charger. Now, this is all dependent on your battery size, how much charge you have left, as I just mentioned. It's a variety of factors, but that's typically what you're going to see. Now, for the purpose of this project, it's fundamentally to identify the best locations to deploy, charging stations. For my use case, I chose to focus on Montgomery County due to its diverse population and landscape. There's a lot of rural areas, but also a lot of suburban and urban areas. Plus, it's where I live. So for those reasons, I thought it would kind of give me a good opportunity to deal with the complexity of incomes, housing types, while trying to kind of balance those landscapes and having kind of that local knowledge. I can kind of, understand if the methodology I'm putting forth is actually producing the correct results. Now, it's going to vary, again, whether it be a level 2 or level 3 charging station. But at the end of the day, I want my methodology to be more or less universally accepted no matter what your inputs are, because it is going to vary state by state, region by region. You are going to prioritize some locations over others, but nonetheless, this framework helps provide a good perspective of its scalability and kind of introduce some complex queries that can intake those data sets into your analysis, if you truly required it. So, by unionizing and aggregating the data sets, you're kind of building those consolidated, features to kind of do your queries on, which you can kind of further exploit if you need to. So my objectives were pretty straightforward. First thing I needed to do was process my data after I found it. I did a lot of this through FME, kind of as a proof of concept. Also with Python, I read through a lot of various data sets in numerous formats, whether it be GeoJSON, geodatabases, shapefiles, APIs, CSVs, while trying to streamline all of my processing, correcting their attributes and ingesting them into my Postgres database. I also needed to kind of gain an overall understanding of my baseline data. I needed to understand their attributes. What are their outliers? Is there any data cleanup I need to do, especially geometry-wise? There was a ton. I can't make informed queries unless I know exactly what I'm kind of looking at. I also need to kind of build a baseline. So I had to kind of understand what was near existing infrastructure or the nearest electric vehicle charging stations, which kind of helped kind of build that understanding, kind of refine what my distances would be to kind of do my deployments, and also kind of identifying massive gaps in our infrastructure. Metro stations or, MARC train stations, for instance. I mean, a majority of them didn't have charging stations within 500 feet of them, which I just found very surprising. But once I understood all that, it did help me kind of write my queries and establish my views, which I'll demo in a little bit. So in order for me to kind of get my project kicked off, I actually need quite a bit more information than what I had originally intended. Luckily, I had 3 sources that acted as my pinnacle of data to kind of obtain a lot of my statewide information, such as my roads, my exits, and kind of things like that. So Maryland's IMAP was a great resource, great portal kind of obtain that information. Montgomery County had a great data set on buildings within the county that could help exploit with a variety of attributes, which was pretty good. I'll kind of get in that a little bit later, some constraints that I had as well. And of course, I used the National Renewable Energy Laboratory as part of the Department of Energy, which had a beautiful API that stored a nationwide data set on existing electric charging stations, which was a huge relief from having to use a third party's proprietary API. Since I was doing my focus on a singular county, Montgomery County, I was able to then apply a variety of textual and geospatial filters to my data sets to extract what I needed for my specific area. Now, a lot of these are large pieces of infrastructure and they don't change frequently. So, every couple of years, these data sets might get updated, but the one that does change the most often would be the EV charging station API. But again, that was automated through Python, so it is very easy to identify those, last updates and then, apply it to my data sets. So I knew I couldn't just throw down 1,000 charging stations and call it a day. I had to work within some, kind of some restraints or some confines, which is like the real world, right? You have budgets and things like that. Fortunately, it's more or less independent of the methodology itself. So I could make up whatever number of charging stations I needed. I could say 5, I could say 500 or 1,000. My process should still work. So within my scenario, I'm going to deploy 9 superchargers and, whether it be off of highway exits or main roads, and about 30 level 2 chargers, and we're going to figure out kind of where they go throughout the demonstration. So before I begin, let me explain what you're looking at. The red charging icons are your existing available superchargers. The blue charging icons are your existing level 2 chargers. Now, what you're going to see happen are orange charging icons appear once we start to deploy our proposed supercharging locations, and the light blue charging icons when we deploy our proposed level 2 chargers. The green lightning bolts will indicate possible site locations based on our exit highway query, and black lightning bolts will indicate possible site locations based on our major roads. I'll keep the legend visible so you can see. So the first part of my scenario is deploying the superchargers. In the back end of this interface, there's a complex query that's doing a couple things. It starts by filtering out only the existing superchargers that currently exist. As you can see, there are 3 superchargers currently available in Montgomery County. It then performs a distance analysis to find the highway exits that are furthest away from the superchargers and only shows me the furthest exit site location to inspect first. The reason for that is because we want to try and resolve the longest distances as quickly as possible. Finally, the query cross-references those exits against all of my possible charging sites, aka my retail shops, grocery stores, golf courses, or whatever else I want to be within my aggregated site. So as you can see, we're going to turn on the layer. Green lightning bolts appear on my map, indicating the proposed site locations. Now I can zoom in. Let's zoom in as much as we can. And as you can see, the Clarksburg premium outlets appeared, where all those retail shops are located. It's a prime location. So now I can easily drop a point of where I'd want my supercharger to be. Now an orange icon appears on my map to show me where my proposed supercharging location would be. Now remember how I told you my query starts by filtering out what currently exists? Well, now it takes that proposed site location into consideration and reprocesses the query and will find me the next furthest exit. So what I can do is I can zoom back out to all of Montgomery County, and you can see my orange charging site still there, but the green lightning bolts appeared over here in the southeastern part of Montgomery County. So at the end of the day, this is very much an iterative process where each time I deploy a proposed supercharger, it will reprocess the query so I can continuously find the exits that are furthest away from both my proposed and active supercharging sites. So what we're going to do is that we're going to go ahead, just do one more example, and we can see the clusters. We're going to accept this position, and we're going to go ahead and we are going to add it to this map. So now that we've added this supercharging location to the map, we can again zoom back out and continue to reprocess the information as it appears. Now, to not bore you with putting down a bunch of superchargers, now we're going to fast forward to deploying our superchargers along our major roads. So now that I've deployed those, I can now focus on my major roads. This acts very much the same as most of my exits, but with minor tweaks. So again, I start my filter on all the supercharging sites, including my proposed sites, and then finds the possible site locations in my aggregated list. Again, what's the grocery stores, retail shops, or whatever I want within that list furthest from my superchargers. It then finds the nearest sites closest to those roads. Again, I'm trying to prevent someone from driving any further than they need to in order to get a charge. So I'm going to do 2 things. I'm going to turn on my major roads, and then I'm going to turn on my possible sites. I'm going to zoom in and out to quickly refresh it. And what we're going to see is this giant cluster over here in Poolesville. So I'm going to do the exact same process where I zoom in, I'm going to copy the coordinates, and we're going to go ahead and add our proposed supercharger. So now that we've added our proposed site out there in Poolesville, again, closest to our other major roads, we can see that other locations popped up. Again, I'm not going to bore you with that. What we're going to go ahead, we're going to move on to our level 2 chargers, which is my last scenario. Again, my view of level 2 deployments would focus on enticing those who want an electric vehicle but don't have the luxury of having a garage to install a charger within their home. So what comes to mind for me was targeting high-income individuals in apartment complexes. That way you can get a lot of people with a lot of money, and typically you have parking garages nearby associated with that complex that would be suitable locations for deployments. So we're going to go ahead and start with that. So with that, like I said, I incorporated income within this portion of my analysis. A lot of publications that I read noted that household incomes over 100,000 were more likely to purchase an electric vehicle. So I used that as my baseline to kind of filter out those apartment buildings using some census information. And really, so anything greater than 100,000. And then what I further did to refine my search was to only display the largest apartment complexes again. It's based on square footage. Obviously, or the data I had didn't tell me how many people resided there, so I kind of just used the square footage as my baseline for this example. Now, this is not an iterative process, so it's not like we deploy one and it disappears and go ahead and we deploy another. The reason for that is I didn't think it could be fully automated. I think there's a little bit more research that needs to go in before you just start throwing down points. What I found out was that the fidelity of the data, although it was good, it was not great. On occasion, you might have a housing complex that maybe wasn't the most ideal, like a senior living center, and I just didn't think it was wise to say, well, you have to deploy something here before we move on. You kind of want to do that analysis, before you start to deploy your stuff. Nonetheless, the base query very quickly identifies a plethora of great spots. I checked the monthly rent on over a dozen of these buildings. I'm going to go ahead and turn them on. They're going to look like little black dots, but you can kind of see where some of those high income areas are with large buildings. We're going to go ahead and zoom in here. And if you know anything about Montgomery County, the Ketlands is a very high income location. And we can go ahead, you can find out a little bit more about that apartment complex, the Colonnade condos. But again, a lot of these apartment complexes were over $3,000 a month for rent, $3,000 to $7,000, which is exactly who I'd be targeting because I'd expect those types of individuals to be able to afford an electric vehicle. So those are the places I would want to deploy first prior to either following or identifying smaller complexes that are still high income or start moving into lesser income areas. So again, this process is exactly the same. Again, since I know this is a shopping center, it would make sense to deploy there. But again, it's the same process. I'm going to go ahead, copy my coordinates, deploy my level 2 charging station, and we're going to go ahead and move on. Okay, so now that I've put down my level 2 charging site at that site complex, I can go ahead and I can continuously put down really as much as my scenario allows. But at the end of the day, I kind of thought to myself, how can I improve this further? So what I kind of came up with are your quote-unquote must-have sites, which should actually be done probably at the beginning of this entire process, especially if you're deploying the superchargers, since it's an iterative process and it will have an impact on the queries more substantially. So what immediately came to mind are the major shopping malls or outlets or for superchargers, and from a level 2's perspective, locations such as ballparks, stadiums, your train stations, or any highly used amenities within your community that people spend a lot of time at. Now, this is going to vary county by county, which is why I think the best approach is to work at the smallest level possible to ensure your tax dollars are being used wisely. So at the end of the day, I created a methodology supplemented by my queries that should actually be done in parallel with each other. My recommendation would be to deploy something kind of like the table below, where there might be unique cases where you might want both superchargers and level 2 chargers at the same location, whether it be at large shopping centers or where shopping times kind of vary, or even golf courses where you can hit a range of balls in like 30 to 40 minutes or play a full round in 4 to 5 hours. I do want to say that I think it's kind of wrong that if we prioritize only supercharger sites simply because they're faster, you're fundamentally kind of only serving the existing customers to kind of relieve their range anxiety on highways, vice the ultimate goal, which is getting more customers into electric vehicles. And the only way you're going to do that is if you give them the same experience as those who have the ability to charge while they sleep and have a full charge every morning. That's why I try to focus on apartment complexes. And then those same people can go on a road trip and be confident there's a charging station just off the next exit. So this kind of brings me back full circle, where I wanted to break the mindset that charging stations need to be as accessible as gas stations. They don't. They are not equal. You don't have the ability to install a gas station in your home, but you do have the ability to install a charging site at your residence. That fundamental reason, alongside that a gas station takes 5 minutes to fill up and a charging site can take 8 hours, it just doesn't make sense to have them on every corner. The only way you can make this work is if you make the convenience there to justify the reason to switch to an electric vehicle. And I think this analysis of how to smartly deploy these charging sites is the first step forward to actually making that a reality. So what I'm going to do is go ahead and reprocess my map to kind of show you a kind of completed view based on my scenario, including my revised order of my deployments, which will include my must-haves as my first step to kind of show you what Montgomery County could look like, again, working within the confines that would basically be in reality. So what you can see here, so this is what the final proposal would look like. And this takes the must-have locations into consideration, which I deployed first for the supercharging locations. And I was able to deploy the 9 superchargers that were within our budget, and also 30 level 2 charging stations at various locations, including your train stations that I use kind of as my must-haves, as long as some of the largest apartment complexes that would serve the highest income individuals within Montgomery County. And luckily, some of them were nearby train stations, so it was kind of 2 birds with 1 stone. And I was able to actually kind of get more bang for my buck that way. Okay, so now that we've seen a map, how about some hard numbers? When we look at the first table, we can see we resolved a lot of our farthest exits from superchargers by over 90%, making it much more accessible. The second table now shows the current furthest exits from superchargers, going from originally 9 miles now down to a much more manageable 4 miles. We can also see a significant decrease in the average distance from the exits in superchargers, down from 3.5 miles, now down to only 1.6 miles, over half from what it originally was. The last thing I wanted to mention is that by deploying just 7 of our 9 superchargers off of highway exits, we actually decreased the distance on 48 exits, which accounts for about 60% of our highway exits within Montgomery County, demonstrating the major efficiencies gained by smartly deploying our supercharging locations. Okay, so where do I go from here? One of the things I think that I could really try to focus some of my future research on is trying to enhance some of the automation I've already kind of tinkered with, whether it be Python writing directly to the database, kind of bypassing FME completely. I think that can be done. Likewise, updating some of my database structure, which might allow for either more enhanced queries. That way I can try to resolve some of those issues of larger apartment complexes once I do deploy those. But I think one of my constraints that I'm having is finding a very solid database with the buildings and all the metadata associated with them. That is a big constraint, and I think my research would go a long way if I could find something for a more robust data set. That way I actually know this is a grocery store, this is the name, this is how many people live within this apartment complex. I really think that could very much enhance kind of my analysis, but also kind of that precursor analysis to really kind of dive into as to what exactly are existing charging stations near, because it is kind of a vague understanding at this point. And ultimately, I think I'll probably bring this into my capstone for next semester. This is something I definitely am passionate about. I think there's a great use case and it's relevant, it's timely, and you can kind of demonstrate that to scale all of Maryland. But I kind of need those data sets there in order to kind of fully bring this, full circle to demonstrate that scalability, but also be able to demonstrate that it works. Anyways, thank you guys all for listening, and I really hope you enjoyed my project.